Hi friends, my name is Baji. Welcome to our channel. In today's video, we will cover looping structures, which is the second type of control structures. We will try to understand different types of looping structures supported by Groovy with some examples. If you are watching this performance testing must-have skills series for the first time, please watch the previous videos first and then continue this video. You can find the series playlist link in the description. So without any further delay, let's get started. Let's open the Visual Studio Code and start making the notes. I have already created a separate file with the name groovy-part6.groovy. If you want to follow along, you can also create a separate file or you can use any existing file. So our today's topic is looping structures. So we can use various looping structures to iterate over a sequence of values or perform repetitive tasks. For example, if you want to perform a repetitive task in the program, so you can make use of these looping structures. Groovy supports different types of looping structures, same like Java, and they are for loop, while loop, and do while loop. So we will look at each type of loop in detail with some examples. First, we will start with the for loop. Basically, the for loop is used to iterate through a set of values or over a range of values or elements in a collection. So here the collection means arrays, lists, maps, etc. We will discuss more about collection in the upcoming video. Okay, we have two different types of for loop syntax. First we will look at the classic loop and then we will look at the second one after that. Okay, so the syntax for classic for loop is, first we need to write for keyword and within parentheses we have three parameters. The first one is the initialization. Since we want this code to be executed over n number of times, we should have a variable to keep track of the iterations. So we will use this initialization section to initialize that loop counter variable. Okay, after that we will specify the semicolon and then the condition. Here we will specify the condition, so the compiler will come and validate this condition every iteration. If this condition evaluates to false, then it will terminate the loop, otherwise it will go to the next iteration. Okay, and then semicolon again, and the next parameter is update. So here we will specify how we want to manage the loop counter variable, whether we want to increment the loop counter or the decrement. For some reason, if you are not specifying the update, then the condition will never evaluate to false and this loop is going to be an infinite loop. So this will run forever. Okay, so that is why we need to specify the update. After that we will specify the opening curly braces and then we will specify the code that we want compiler to execute in each iteration. And finally, we will specify the closing curly braces. So this is the syntax of classic for loop. So let's look at the example now. First, we need to write for keyword, opening parenthesis. The first parameter is initialization. So we need to initialize a loop counter variable. So let's declare a variable called I. So def I, and we will initialize with 0. Okay, then semicolon. Then we need to specify condition. So we want the loop to be executed 5 times. So we can say that, run the loop until I reaches to 5. How we can say I less than 5. Here I am not using less than or equal to, right? So this loop will run until I reaches to 4. Once I becomes 5, this loop will terminate. Okay, and then next semicolon. After that we need to have an update. So we need to increment I in every iteration, otherwise the I remains 0 and this condition will always true and the code that we are going to write inside the loop will execute forever. So to avoid that, we will put the update statements. So here we want to increment I, so we can say I++. So here I am using unary increment operator, right? And then the opening curly braces. Here we need to specify the code. So what we want to do in this program, we want to print hello groovy 5 times. So let's write the println hello groovy. So let's run the program and then see if we are getting the expected output. To run a Groovy program, we need to go to terminal and type the command groovy space file name. So the file name is groovy-part6.groovy. See, here we got hello groovy, hello groovy, hello groovy 5 times. If you want to rerun the same program for 50 times, you just need to update the conditions. Let's say 50 here and then rerun the same program and see what will happen. This time compiler will print 50 times. So if you don't have loop concepts and if you want to print hello groovy, then you need to write 50 times, right? That will be a tedious task. So to overcome such requirements, every programming language introduces this loop concepts so that we can iterate particular task repetitively. Now let's quickly look at the another example. Let's say we are poor at math and we wanted to develop a program which will print a math table for us. So we want a math table in this format. Okay, so we want like 3 ones are 3, 3 2s are 6 until 60. So example purpose I just gave 3, but we can use any number to print this kind of math table. We will make use of the classic for loop to achieve this output. First let's declare a variable which will be used to print the math table for the given number. So we can use def num equal to, let's say we want to print 18th table. So we will use num equal to 18th. Okay, and then we will use the for loop. So for loop syntax for opening parenthesis, first we will initialize loop counter. So we can say def I equal to 1 because we want want math table to start from 1, right? So like 3 1s are 3, 3 2s are 6. We don't want 3 0s are 0, 3 1s are 3. So we want our math table to begin from 1. So that is why I am declaring I as 1 semicolon. And the next is conditions. We want this loop to be run for 20 times. So we can say I less than or equal to 20. Since I am starting from I am using the equal to, so that it will also consider the value of 20 in the condition. This condition only evaluates to false once I reaches to 21. So we can see the output until 20. And then we will use the increment operator to increment the I for every iteration. So opening curly braces, after that here we need to write the print statement in this format. So we can use the string interpolation to get similar output. So first we need to write println double quotations. So first we want to print 3. Here 3 means the number. So the num variable. So let's write num, and then we want to have an into symbol. So into, when you are not using string interpolation and within double quotation, anything that you are specifying, compiler will print as is. Okay, so the x will be print as is, and then after that we want to print 1 2 3 4 5 6 until 20. So we have a loop counter variable which is I that holds the iteration number. So it will start with 1 and then it will go to until 20. So we can make use of that here to get the desired output. So we can say dollar curly braces and I. So we need to give space also, otherwise it will mix up everything, right? Here also we have a spaces, so better to give some space. So and then space equal to, and finally we want num into I. So that means the number will be multiplied with I every iteration. So first time it will be 18 into 1, and then 18 times 2, 18 times 3, 18 times 4, and so on. Okay, let's try to run the program and then see if we are able to print the math table of 18. So we got the desired output, right? So it printed the way we want. Let's say if you want to print 24th table, so you can just simply change the num to 24 and then rerun the same program. See, you got the 24. So if you want to print any table, you can make use of these 3 lines of code and then print the table. Okay, before we start the discussion of second type of for loop syntax, let's quickly understand the range operator. Basically, a range is shorthand for specifying a sequence of value. It is denoted by the first and last value in the sequence, and it can be inclusive or exclusive. An inclusive range includes all the values from the first to last, while an exclusive range includes all the values except the last. Okay, Groovy provides a notation of 2 dots to create a range of objects. So we can use this syntax to create a range of objects. So let's look at the examples. So we can define a range like, let's say if you want to create a range between 1 to 10, so you can make use of this range operator and define like this. So we can say 1 dot dot 10. So when Groovy sees this line of code, then it will understand that this is a range which needs to start from 1 and then end with 10. So it will take 1 2 3 4 until 10. Okay, so this is an example of inclusive range. If you want to include 10 in the range, you can use the exclusive range. So the way we will define is again starting range number dot dot and then the less than symbol and the last range number. So if you specify like this, then the compiler will use the sequence starting from 1 to 9. It will not consider the last number, which is 10 here. Okay, so this is exclusive range. So the range is not only meant for numbers, you can also use for characters. So we can also define like a dot dot x. Since these are character, we need to surround them with single quotations. Okay, this is for character range. So here also we can use the exclusive and inclusive syntax, and even you can use the reverse way as well. Let's say you want to have a range starting from 10 and go towards 1 in a descending manner. So you can also define 10 10 dot 1. So this is also an acceptable range. Okay, we have different types of methods available for these ranges. Basically, a method is nothing but a set of code that is written by the developer, right? I mean, we don't need to rewrite the same code. We simply can make use of that method and achieve the purpose of that method. Okay, so let's look at the first method, which is contains. So this method will check if a range contains a specific value or not. Okay, so we can make use of this method and then verify if any specific value is available in the given range. So let's quickly write a simple program to understand how this contain works. Let's define a range. Let's say num range equal to 1 to 10. Here I am using the inclusive range, so I'm not excluding anything here. Okay, now let's use the println statement and try to use the contains method. So we can say the variable num range dot contains. So within the parentheses, we need to specify the number that you want Groovy compiler to check in the range. Let's say we want to check number 6. So we want to verify if number 6 is available in the given range. So we can write like this. So number range dot contains within the parentheses 6. Let's run the program. So it is telling true. That means the number 6 is available within the range. Let's make this as 14 and try to rerun the program. So we should be getting false because 14 is out of the range. Okay. And the second type of method is get. Using the get, we can retrieve the element at the specified position in the range. So you can specify some position within the get method, and Groovy will look into the range and then return the element in that specified position. Okay. So let's try to use again println space num range, which is our range variable, and then dot get. So here we want to retrieve the element to the position 5. Okay. So let's try to run the program and then see what is the output that we are getting. So we are getting 6. So at position 5 we have the actual 6 number. Okay. You can also try to print position maybe 7 and then see what the value we are getting, number 8. So the next method is get from. If you want to get the lower value of the range, then you can make use of this get from method. So let's try to println again num range, which is our range dot get from. So here we don't need to specify any options within the parentheses. We just need to specify the method name dot get from. So when you run this program, it will try to print the lower value of the range. Let's try to run the program. See, the lower range is 1. So the range starts from 1. That is why it is printing 1. And we have another method called get to, which we can use to print the upper value of the range. So println num range dot get to. Try to run the program. So we are getting the upper range, which is 10. And the final method is size. We can make use of this size method to understand the number of elements in the given range. Let's try to print the size. Println num range dot size. Here also we don't need to specify any options within the parentheses because we are trying to understand the total size of that range. So let's try to run the program. The size of the range is 10. So there are 10 elements in that range. Okay. Now let's look at the second type of for loop, which is for in loop. So this for in loop syntax can be used to iterate over ranges, collections like arrays, lists, and maps, or any objects that implements the iterable interface. So in Java, we have a interface called iterable, and whichever the object that implements this interface can be used with this for in syntax. Okay. In Java, we are using for each to iterate over ranges. In Groovy, we are using for in, but we still can use for each loop in Groovy as well because Groovy is a superset of Java. So let's try to understand the syntax first, and then we will see some examples. First, as usual, we need to give the for keyword, and within parentheses, we should be specifying item in iterable. Iterable is the object over which we are iterating, and the item is a variable that represents the current item in each iteration. So the loop will iterate over all the items in the iterable object, and this item will hold the current item of that particular iteration. Okay. And after that, opening curly braces, and then we will specify the code that we want to Groovy compiler to execute for each item, and then the closing curly braces. Let's look at the example now. Let's say we want to print numbers from 1 to 5. So we can define that 1 to 5 as a range, and then we can make use of this for in loop to print those numbers. Let's define a numbers range. So def numbers, we want 1 to 5 numbers in the range. So 1 dot 5, and then we will use the for loop. So we need to define the item. So we can use of def keyword and then the item name. So we can say num and then the keyword in, and then the iterable. Here the iterable is a range. So we can specify the numbers variable which holds the 1 to 5 range. Okay, and then opening curly braces, and then we want to print the number in that range. So we can say print ln num, because this num holds the current value in that iteration. Let's say in the first iteration, this num will have first because this numbers is holding a range which starts from 1 to 5. This is inclusive range, so we are not excluding anything. So it will start from 1 until 5. So first iteration num will hold 1, then in the second iteration it will hold the number 2, and the third iteration number 3, and so on. So we are trying to print that num because that holds the current value. So here we don't need to specify any condition or any increment like the classic for loop. Okay, so the Groovy compiler will check the iterable object and it will terminate at the end of that iterable object. Okay, so let's try to run the program and then see if Groovy compiler is printing numbers 1 to 5. So we got the required output 1, 2, 3, 4, 5. So using this for in loop, you can iterate over ranges. You can also make use of the loop to print the numbers in the reverse order. So while I'm explaining the range operator, I mentioned that we can also define the ranges in the descending order as well, right? So we can specify the lower value as 5 and then the upper value as 1. So when Groovy sees this code, it will start the loop from 5 and then it will decrement until it reaches to 1. Let's try try to rerun the program. So here we are getting 5, 4, 3, 2, 1. Okay. We can also use for characters also, right? So let's say if you want to print alphabets starting from A to Z, then you can define that as a range. So let's comment out this program and we will use the new program. So let's define characters range as A to Z. So this dot dot we can also pronounce it as 2. So A to Z. So we are defining a character range starting from A until Z. And then the loop. So for we need to define a item variable, right? So let's say define character in the iterable. So which is character. So because the character holds a range, and then putting curly braces, println, you want to print a character. So let's remove the ln. We want to print all the characters next to each other. So that is why I'm removing the ln keyword. So it will not print every character in a new line. Okay. So let's try to run the program. So we got A, B, C, D, E, F, G, H, I, J, K, L until Z. Okay. We can also do the same thing in a reverse order. Let's make it Z to A. So if you want to see the output in the reverse order, you can also do that by defining a range from Z to A. Okay. So here the output we got Z until A. So Java supports for each loop. The only difference between for in and for each is instead of writing the in keyword, you can use colon. So if you write like this, then you are kind of using the Java type of syntax. So we can rerun the same program and achieve the same out. So you can either use in or colon. In is kind of a Groovy keyword that they're specifying it for in loop. So let's try to rerun the program. See, we got the same output. So you can use colon or you can use in. Since we are using Groovy, so I would recommend to use in to avoid any confusion in the code. Okay. So this is the second type of for loop. Now let's quickly understand two keywords, break and continue. While discussing the switch case control structure, we discussed about break, right? So it will terminate the control structure from that point. So whenever Groovy compiler sees the break statement, it will terminate and come out from that control structure. So we can use the break in loops as well. So let's try to run a program. Let's say if you want to print the numbers in the range, and if the number equal to 3, then we want to come out from the loop. Okay. We don't want to print rest of the numbers. So let's define a variable again, numbers. We will say 1 to 5. So this is the range that we are defining. After range definition, then we need to write the loop. So for def number, we are defining the item in iterable objects, which is numbers, and then the opening curly braces. After that, we can write the if condition because we want loop to terminate once it sees the value 3. So we can say if within the parenthesis, we can give the condition if number equal to 3, then we want break. So we want this loop to be terminated. So let's try to run the program and then see what is the output that Groovy compiler is giving. It did not give anything because we did not print anything, right? So there is no println statement. So the loop simply executed, Groovy terminated the program. So let's try to print the numbers as well so that we can clearly understand. So println number. So let's rewrite the program again. So now we are getting 1 and 2. So the way the program will execute it, so in every iteration, the number will hold the element in this range, right? First it will hold number 1, then the compiler will come to line number 83, it will check the condition. If the value inside the number is equal to 3, so first time it holds 1, so 1 not equal to 3, then it will not go inside the if condition and it will go to line number 86. So it will print the number and then it will go to the second iteration. In the second iteration, the number becomes 2. Again here, is number 2 equal to 3? No, it will not go inside the if condition. It will go to the line number 86 and then it will print the number. And then in the following iteration, the number holds 3. Number 3 equal to 3? Yes. Then it will go to inside the if condition and it will try to break. When Groovy compiler sees the break, it will terminate the loop and it will come out here. So that is why we only see 1 and 2. It did not print the rest of the numbers. In the if condition or even the for loop, if you are only having one statement, then you don't need to specify the opening and closing curly braces. You can also rewrite the same thing like this as well. So let's try to rerun the program again. So we got the same output. You only need the curly braces if your block contains 2 or more lines of code. Okay. To avoid any confusion in the beginning stages, you try to specify the curly braces as well. So this is all about break. Now let's look at the continue. So let's copy the same program. So using the continue statement, we can tell the compiler any statements after continue statement, don't execute in that current iteration and simply start the next iteration. For example, if I specify the continue here, then what will happen is when the compiler evaluates this condition as true, then it will come inside this, right? So when it sees this continue, then it will not execute any code after this continue statement. It will simply start again and it will simply go to the line number 2 and start the next iteration. So that is the main difference. When compiler sees the break statement, it will terminate terminate the loop, but the continue, it will not terminate the loop. It will simply skip the rest of the code in that current iteration and start the next iteration. So let's try to rerun the same program and then see what will be the output. So here we are getting 1, 2, 4, 5 because this condition says if number equal to 3, we are specifying continue. We don't want to print anything after that, right? This is all about the continue keyword. Now let's look at the second type of looping structures, which is while loop. With the help of while loop also, we can iterate over a sequence of values. The only difference between for loop and while loop is the syntax. Let's look at the while loop syntax now. First, we will use the while instead of for keyword. So while, and then within parentheses, the condition. So we will specify the condition. If this condition evaluates true, then the compiler will execute the code mentioned within this block. If the condition evaluates to false, then this will skip. In for loop, we have 3 parameters, right? Like the initialization, condition, and then update. But here we have only condition, and the other parameters we need to manage. Let's look at some example to understand this while loop. We will write the same program to print numbers 1 to 5 using while loop as well. Okay. First, we will define a variable called I with some value, start with 1, and then we will specify the while loop. So the syntax for while loop is first we need to write the while keyword, and within parentheses we need to specify the condition. So here we want numbers to print from 1 to 5, so we can say I less than or equal to 5. We want Groovy compiler to check the value inside the I. If it is less than or equal to 5, then we want this loop to be executed, right? So this is the condition that we want to write it here, and then after that opening curly braces, and here we want to print I. After print I, if you are not doing anything, if you simply run this program, then what will happen is this loop will never end, because in line number 105 we are specifying a condition I less than or equal to 5. That means we want compiler to check if the value inside I is less than or equal to 5, right? First it starts with 1. Is 1 less than or equal to 5? True. So then it will come line 106 and print it. After that it will go back to 105, then it will check again. Is 1 less than or equal to 5? True. Again it will print 1. So this will happen and again and again and again. To avoid that situation, what we need to do is we need to increment the I variable. So how we can increment? We can make use of the unary increment operator. So we can say I plus plus, or you can even say I equal to I plus 1. Let's try to run the program and then see what will happen. So we got 1, 2, 3, 4, 5. Since I did not use the print ln, it just printed one after another. So we can even write the println and then see what will happen. So now we have the output in each line, like 1, 2, 3, 4, 5. So this is all about while loop. So the final type of looping structure is do while loop. So let's look at the syntax. After that we will look at some sample program. Okay. The syntax for do while loop is first we need to write do keyword and then opening curly braces and the code that we want to repeatedly execute, and after that closing curly braces and then while within parenthesis condition. So the difference between while loop and do while loop is irrespective of condition, this do while loop at least execute once, because at the beginning we are going inside the loop directly, right? We are not checking any condition. But if you see the while syntax, it will first evaluate the condition. It will only go inside the loop if the condition evaluates to true. But here in the first iteration we are not evaluating any condition. We are directly executing the code and then we are evaluating the condition. So that is why this loop will run at least once. So we can rewrite the same example. We say if I equal to 1 and then do keyword opening and closing curly braces. Within that loop we want to print I, and then after closing curly braces we will specify the condition I less than or equal to 5. So we will be getting the same output. So there is no difference. Try to run the program and then see. I forgot to mention the increment. That is why it went into the infinite loop mode and it's continuously printing 1. So after println we also need to have an increment of I, right? So we need to use the unary increment operator to increment the I. Now let's try to run the program. Now we got the same output 1, 2, 3, 4, 5. So that's it for this video. Thank you so much for staying till the end. I hope that was informative and you understood all the concepts explained in this video. In case any specific concept is not clear or requires more detailed information, please feel free to mention it in the comment section. All the notes have been uploaded in GitHub and you can find the link in the description. If you are new to our channel, if you enjoyed this video and found the information helpful, please consider subscribing our channel. By subscribing, you will stay updated on all our future content. If you like what you saw today, please give this video a thumbs up. Your support means a lot and helps me continue creating content for the community. If any of your friends are interested in learning performance testing, please share this series links to them so that they will learn all these concepts for free and get benefited. I'll see you with our next video in this module. Until then, take care, stay safe and keep learning.